Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine standing in the heart of a dense, ancient forest during a summer storm. As the wind howls through the canopy, the giant oaks and towering pines sway violently, their massive trunks groaning under the mechanical stress. To the casual observer, this is just a display of natural power and resilience. But beneath the bark, at a molecular level, something far more mysterious is happening. These trees aren't just surviving the wind, they are harvesting it. Welcome to the world of the piezoelectric forest, where the very act of bending in the wind transforms wood into a biological power plant, generating currents of subterranean electricity that pulse through the earth. To understand this phenomenon, we first need to talk about piezoelectricity. Derived from the Greek word piezo, meaning to squeeze or press, this is a physical property where certain materials generate an electric charge in response to applied mechanical stress. You encounter this every day. It's what makes a quartz watch tick and a barbecue lighter spark. Historically, we thought of this as a property of crystals and specialized ceramics. However, biological materials are surprisingly adept at this trick. Bone, tendon, and even DNA exhibit piezoelectric properties. But it is in wood, specifically the cellulose and lignin that form the structural backbone of trees, where this effect takes on a planetary scale. Cellulose is a complex carbohydrate that arranges itself in highly ordered, crystalline microfibrils. When a tree sways, these microfibrils are stretched and compressed. This mechanical deformation shifts the internal charge distribution within the cellulose molecules, creating a measurable voltage. Because a forest consists of millions of tons of wood all swaying in unison, the cumulative effect is staggering. Every gust of wind acts as a giant hand pressing down on a massive, living circuit. This process isn't just a physical curiosity, it is a fundamental part of how the forest interacts with its environment. But where does all this electricity go? The answer lies beneath your feet. A tree is not an isolated organism, it is anchored into a vast, damp, and conductive medium, the soil. As the trunk generates a charge, the roots act as electrodes, leading this energy into the subterranean environment. This is where the story gets even more fascinating. Forests are interconnected by the mycorrhizal network, a complex web of fungal filaments that link the root systems of different trees. Recent research suggests that these fungal highways might act as biological wires, distributing the wind-generated electricity across the forest floor, creating a literal, wood-wide web that is electrifying. This subterranean current isn't just a byproduct of physics, it may serve a profound biological purpose. Electricity is the universal language of cellular signaling. By pulsing low-voltage currents through the soil, trees might be communicating environmental stress to their neighbors long before the wind reaches them. Furthermore, these electric fields can influence the movement of ions, like nitrogen and phosphorus, through the soil, potentially charging the roots to help them absorb nutrients more efficiently. It is as if the forest has engineered its own power grid to optimize growth and survival in real time, using the energy of the storm to fuel its development. The discovery of the piezoelectric forest challenges our traditional view of botany and physics. We often think of trees as passive observers of the environment, but they are active participants in the Earth's electromagnetic landscape. Engineers are already looking at liquid wood and cellulose-based nanogenerators as a way to create truly sustainable green energy. Imagine a future where our buildings, made of engineered timber, generate their own electricity every time the wind blows or someone walks across the floor. Nature has been using this technology for millions of years, turning the chaos of a storm into a structured flow of energy that benefits the entire ecosystem. As we delve deeper into the secrets of the woods, we find that the line between biology and electronics is thinner than we ever imagined. The forest is not just a collection of plants. It is a giant, rhythmic machine, pulsing with hidden currents that sustain the delicate balance of life. The next time you see a tree swaying in a breeze, remember that it is doing more than just dancing. It is powering the hidden world beneath the soil, proving once again that nature's engineering is far more sophisticated than anything humans have yet devised. For more incredible facts like this, don't forget to subscribe and turn on notifications.